Today we're going to talk about our double replacement reactions. So, if we look, our learning target is the same learning target that we've had for this entire unit to classify the types of chemical reactions. Now, our success criteria for this particular video, the double replacement reactions, we need to, number one, be able to balance a chemical equation. We need to be able to describe/identify a double replacement reaction. We need to be able to predict a double replacement reaction. And finally, we need to be able to determine solubility using our solubility chart. That's why I wanted you to get out that chart with your reaction prediction packets. Now, when we're thinking of a double replacement reaction, we are thinking of two compounds being our reactants. So what's actually going to happen? If we look here, AB plus CD, what we're going to do is we're going to flop. And in this one, it says flop the B and the D. As you will see, and it's the same thing you're doing when we're doing these actual reactions, we're going to flop the cations, which would have been the A and the C, this one. But if you flip the A and the C, you're going to still get CB, and you're still going to get AD for your products. Okay? So basically, we are just switching the cation partners with the anions. Now, as I look at this, here's our first example, but let's look at our different types of double replacement reactions. As you can see up here, way up here at the top, two aqueous salts yield two new salts with at least one a precipitate. Now, what is a precipitate? Anyone have any idea? It's a solid, okay? It's a solid that will eventually sink to the bottom of your particular reaction environment. Now, if we look at 2, 3, 4, 5, 6, what do they all have in common? An acid. All right? So, we're only going to be needing our activity series, check, our solubility chart with the double replacement number 1. If we have 2 through 6, they're dealing with acids. We don't need to look at that solubility chart. Matter of fact, look at your solubility chart. Is hydrogen even on it? Not even on it, is it? Okay? So if you would go to even look up one of those acids, it wouldn't matter because that is not even on it. Now let's go back here. Do I have an acid? I do not. So that tells me right off the bat, since I don't have an acid, this has got to be a double replacement number 1. A double replacement number 1. Now, look at your reaction prediction packet. On a double replacement number 1, it has 5 different steps that you need to do. A through E. Okay? So how am I going to start right here? Is I'm going to write my formulas for my reactants. Strontium, acetate. Strontium's a 2+, acetate's a 1-. Plus, calcium is a 2+, chromate is a 2-. So I have calcium chromate, I have strontium acetate. Now, letter A, step A, tells me to determine the possible products by swapping the cations. So what I'm going to do is I'm going to take this SR and this Ca, and I'm going to swap them. So it's going to give me calcium acetate, and I'm just going to go below because I ran out of room. So it's going to give me calcium acetate, and it's going to give me strontium chromate. Now, it's very important that you remember, back with all of our nomenclature, okay, back with all of our nomenclature, that you write the correct formulas. So if you need to write out the words, strontium chromate, and then write the formula, that's perfectly fine. Just so bottom line, we get them correct. Okay? So I've now swapped my cations. My next step is step B, check the solubility of both possible products. Now, it says products, okay? It says products, not reactants. The reactants have to be aqueous salts. We already know that. Excuse me. So we need to go through our solubility chart and test our products. So the first one I'm going to look at is calcium acetate. What does calcium acetate give me? It says that it is soluble. So since that is soluble, behind it I'm going to put an AQ because I know that it'll dissolve in that water. It's aqueous. Strontium's down at the bottom. Strontium chromate gives me what? An I. It tells me it's insoluble. So if something is insoluble, I need to put that it is a solid. Now, if I don't put aqueous, and I don't put solid on these double replacement number ones, you're going to miss points. They are required. You have to state which one is aqueous and which one is a solid. Step C says if both products are soluble, then no reaction. Do I have that in this case? I do not. I have an insoluble one. Step D says at least one reactant must be soluble and aqueous to have a reaction. Well, do I have a soluble aqueous one? I do. And step E says to use the appropriate symbols. Solid, aqueous. Up arrow means a gas. Down arrow means a precipitate. Okay? So if I wanted to on this, instead of having this solid here, could I have a down arrow? I could, but I think it's better off putting the solid. Now, I know this reaction occurs. So now, what I need to do is, final thing, do I have a balanced chemical equation? And by looking at this, do I? I do. Okay? I do. So ladies and gentlemen, right there is your double replacement reaction of sodium acetate and calcium chromate. Any questions for me? Here's number 2. Go ahead and copy down our second example. Do I have an acid? I do not. So that tells me this is a double replacement number 1. So what I'm going to do first of all is I'm going to get my formulas for rubidium bromide. Rubidium's a 1+, it's an alkali metal. Bromine's a halogen, so it's a 1-. Silver is a 1 plus. Fluorine's a 1 minus. So there are my two reactants. Once again, my first step, a double replacement number 1, tells me to swap the cations. So when I swap the cations, I get AgBr. Both of those are 1. 1 plus, 1 minus. And then I'm going to get rubidium fluoride. RBF. So I have swapped my cations. Step B says to check the solubility of the products. So I'm going to go through and check AgBr, silver bromide. Gives me an I, correct? So that tells me that it is a solid. It's insoluble. RBF, rubidium fluoride. Gives me an S, so that tells me that it is soluble. So I'm going to put my AQ behind that one. Once again, if I don't have the solid in the AQ, you're going to be missing out on some points. Now, if both products are soluble, no reaction. Well, that's not the case. At least one reactant must be soluble and aqueous to have a reaction. We've got that. Use appropriate symbols. We've done that. Now, my final thing, am I balanced? I am. I am. So, we are finished with this double replacement reaction. Here's our third one. Sodium phosphate and silver nitrate. Sodium phosphate and silver nitrate. Do I have an acid? No, I do not. So this is a double replacement number 1. Once again, this time, sodium is a 1 minus, or excuse me, a 1 plus. Phosphorus is a 3 minus. So right there is sodium phosphate. I'm going to add to that silver is Ag, 1 plus, nitrate, NO3, 1 minus. So there are my two reactants. Step A says to swap the cations. So I'm going to get sodium nitrate. And I'm going to get silver phosphate. Silver is a 1 plus. Phosphate is a 3 minus. So now I've got my possible products. I need to determine the solubility of both of those possible products. So first one is sodium nitrate. So I find sodium nitrate. It is soluble. So I put an AQ behind that. Silver phosphate. Silver phosphate is insoluble. So I obey step C, because step C says if both are aqueous, it's no reaction. Step D says that at least one reactant must be soluble. Well, I do have that. So I've got my AQ, I've got my S in there for step E. So my last thing I need to do is balance my reaction. Okay? Right now, do I have a balanced reaction? I do not. What's my problems? Yeah, my Ag and my Na, right? So I can see that I have 3 NAs, so I'm going to put a 3 here. I can see that I have 3 AGs, so I need to put a 3 here. And once I have done that, I believe that balances up my equation, correct? Here's my next one. Calcium carbonate and hydrochloric acid. Now, do I have an acid? Yes, I do. So, I know that it's going to be 2, 3, 4, 5, or 6. So let's go and let's start eliminating. Do I have an acid and a salt? Well, what's a salt mean? A salt just tells us that it's something that is ionically bonded. Okay? So, I have an acid. Is this a salt? It is. So I could have a number 2, double replacement number 2. Now, number 3 says that I have an acid and a metal carbonate. Is that an acid and a metal carbonate? Yeah, metal carbonate. So yes. So now, this one trumps it because it's more specific. Okay? Do I have an acid and a base? And a base is a metal hydroxide. Do not. Acid and a sulfide salt. I didn't see any S there. Acid and a sulfite salt. Didn't see that one either. So this is going to be a double replacement number 3. And that tells me on the double replacement number 3 that I'm going to have formed a salt, water, and carbon dioxide gas. Now, do I need to look at my activity, or excuse me, my solubility chart? No, because remember, is hydrogen on there? No. So what I'm going to do is I'm going to take calcium is a 2+. It's an alkaline earth metal. Carbonate is a 2-. My other reactant is hydrochloric acid, IC 1 or 3. This is acid rule number 1. Okay, so that tells me, drop that, not looking at this. I have chloride. So hydrochloric acid is HCl. Now, my packet tells me that a double replacement number 3 gives me an acid, or excuse me, a salt, water, and carbon dioxide. So what is my salt going to be? Well, I'm just going to once again, flop the cations. So my salt is going to be calcium chloride. And then it tells me that I have water and I have carbon dioxide gas. I could put gas in here like there. Okay, water's a liquid probably. It doesn't tell me, but I don't really need to put those things right there. I don't really need to put those on these, only the double replacement number ones. Now, is this balanced? It is not. It is not, because I can see that I have different amount of chlorines. So I'm going to put a 2 here to balance up my chlorines. When I do that, that balances up my hydrogens. My oxygens are at 3, carbons at 2. I've got a balanced equation now. Any questions about this one? Well, good. Lead 2 hydroxide hydrobromic acid. Uh-oh, I have an acid, don't I? I have an acid. So I have to figure out which one, 2 through 6. What do you think? I would agree. Number 4, because it says metal hydroxide. That is this base here. It's going to be a metal hydroxide. Now, if you look on your packet, at the back end of number 4, it says neutralization. This is actually what we call a neutralization reaction, where we will be talking about this. Hopefully, 4th 9 weeks, we will get to acids and bases. So when we get to acids and bases, we talk about neutralization reactions. So basically, my acid plus my metal hydroxide gives me a salt and water. So I'm going to name out, what did I say? Double replacement number 4, right? Lead 2 hydroxide. Lead's a 2+, hydroxide's a 1-. Hydrobromic acid, ICIC, 1 or 3, here's the hydro. Acid rule number 1, bromide. Bromide's a 1-, so it's going to be HBr. Now, my packet tells me that this gives a salt. Well, what's that salt going to be? It's going to be lead 2 bromide. And this is a very important point here, folks. If I have lead 2 in my reactants, I should have lead 2 in my products also. I don't switch it over to lead 4, is what I'm meaning. Okay? If I have lead 2, keep it at lead 2. So this is lead 2 bromide, and my other product's going to be H2O. Don't need to check my solubility chart. I already know that this reaction is going to occur. Now, do I have a balanced chemical equation right here? I do not. I do not. I can see that I at least need a 2 right here because I have 2 bromine. Lead's good. Bromine's good. Hydrogen, 2 and 2 is 4. So that tells me I'm going to have to put a 2 here. 2 and 2 is 4. 2 oxygen, 2 oxygen. Balanced equation? Yes. Iron 3 nitrate and sodium chloride. Do I have an acid? I do not. So I've got a double replacement number 1. So I'm going to find my formulas. Iron 3 plus, nitrate's a 1 minus. So iron 3 nitrate. Sodium 1 plus, chlorine 1 minus. NaCl. So, swap the cations. NaNO3 plus iron 3 chloride. I need to then check my solubility chart. Sodium nitrate. I've already dealt with that. That's an S. So this is aqueous. Iron 3 chloride. I've got an S there too, don't I? So what does this tell me? Huh? No reaction, because step C says if both products are soluble, no reaction. So what I'm going to do is I'm going to get rid of both products. And I'm going to put NR. No reaction. I've only got a couple more to do. Silver bromide, ammonium sulfate. I do not have an acid. So that's going to be a double replacement number 1. I'm going to need to use my solubility chart. Silver bromide. Silver is a +1, bromine's a -1. Ammonium, that's one of our few positive polyatomics. NH4, it's a +1, so I'm going to need 2 of them to go with my sulfate. What I'm going to do then, once again, I'm going to swap my cations. So I'm going to get NH4Br, a +1 and a -1. And I'm going to get Ag2SO4. Now, does it matter what order I have those in my products? It doesn't. I could have the silver sulfate first. I could have the ammonium bromide second. It doesn't matter what order I have them in. I now need to check my solubility chart. Ammonium, the very second one from the top. Bromide, that is aqueous. silver sulfate, silver sulfate tells me it's a SS. What's a SS on our solubility chart? Slightly soluble. If something is slightly soluble, it's very much insoluble. So when we see that SS, we're going to think of that as an I. So we're going to mark that a solid. So will this reaction occur? It will. Okay. So the very final thing I need to do here is I need to balance my equation. I can tell that I need to have 2 ammonia. That's going to give me a 2 right here because I need 2 bromides. I have 2 silver. I think that is a balanced chemical equation. Agreed? Okay. I want you to do, this is the last one we have. I want you to do this on your own. And then after break, I will work this one. So do this one on your own, then I'll work it after break. All right, here we go. This is a double replacement number 1 because I do not have an acid. Ammonium is NH4. It's a 1 plus. Phosphate's a 3 minus. So right there, ammonium phosphate. Nickel 2 chloride. Nickel's a 2 plus, chlorine's a 1 minus. So there's my nickel 2 chloride. Now, my rule says to swap the cations. So nickel 2 phosphate is going to look as so. Nickel is a 2 plus, phosphate's a 3 minus. So I need 3 nickel to team up with my 2 phosphates. My second product is going to be ammonium chloride. NH4 is a plus 1. Cl is a minus 1. So my next step is to check the solubility of my products. So I look at nickel 2 phosphate. That is insoluble. So I put an S after it. Ammonium is up at the top. Ammonium chloride is an S. So that is soluble. So I put my AQ behind it. So will this reaction take place? It will. All I need to do now is balance this. And I tell you, this is a big balance here. I'm going to start with my phosphates. I have 2 on the product side, so I know I'm going to need 2 on the reactant side. So I'm needed to put a 2 there for my phosphate. Next, I'm going to go with my nickel, because I see I have 3 nickel in the product side, so I'm going to go 3 nickel in the reactant side. That gives me 2 and 3, 6 ammonium and 6 chlorine. So if I put a 6 right here, I should have that balanced up. Anybody get it? Just didn't balance it right? Yeah.